Hello and welcome to my academy. Today we'll be studying about types of accelerated motion. As we know that accelerated motion is of two types. First is uniformly accelerated motion. Another one is non-uniformly accelerated motion. So what's the difference? What lies in the difference is when the acceleration of the particle is constant throughout the motion of the particle when it is moving from one point to another point, then in that case we say that it's uniformly accelerated motion. What lies in non-uniform accelerated motion is acceleration of the particle is not constant. It's actually variable. It's dependent on velocity change, and velocity is further dependent on displacement change. What kind of equations we can use in this uniformly accelerated motion is there are three equations that we generally use for non-uniformly and uniformly accelerated motions. For uniformly accelerated, first equation that we can use is v is equals to u plus at. Second, s, or you can say it as x, is equals to ut plus half at square. Third, v square minus u square is equals to 2as. Now what are these things that I've written? What is v? V is actually the velocity of the particle at time t. That is very important, since the particle has traveled from one point to another. For supposedly this is the first point A and this is going from here till here. This is the second point B, and it's taking t time to reach B point, and its initial speed when the particle started was u, and the final speed at this point is v. So v is the velocity at time t, and u is the initial velocity at t0. Unless and until it's not mentioned that it's t0, you will be using t0 only. And what's this x? X is the displacement from A to B. Whatever the displacement would be, then x will be that. And now I'll be coming to non-uniformly accelerated motion. Okay, and after that we will be discussing about the sign convention too, because that is very important in these questions. Okay, let's come to this. It's very simple. What happens here is when acceleration is variable, we use dx by dt equal to v. And second equation that we use is dv by dt is equal to acceleration. These are the equations that we use for the derivation of any kind of equations. This is from the basics of the particle. Okay, and we don't need to use any vector form here, because whenever we are dealing out with straight line motion, we generally don't use vector form, but we use the sign convention. If you're using the sign convention, that's okay, because vectors will involve obviously the sign, and if you don't want to use vectors, you can directly use the sign convention. Okay, now what additional we can say about acceleration? Can you tell me? Can you guess what can be the value of acceleration in terms of displacement? We need to calculate this in terms of displacement. So what we are going to do is we'll write this. Okay, I'm copying it here again, that acceleration is change in velocity upon change in time, and what else we can do is we can multiply it by displacement, change in displacement upon change in displacement, because anything which is multiplied by 1, this is exactly 1, is equal to that number only. So it doesn't matter that we multiply it by dx and dx. Okay, so since now we can say that this dx upon this dt will be what? From here we can say it's velocity. So the acceleration is coming out to be dv upon dx into v. This is the final expression that you will be using. No need to learn it, because you can derive it at the same point of time. And what about velocity? We don't use anything about this, and this is actually equal to, you can say it that change in displacement is equal to velocity into change in time. Remember, these are to change, not exactly the displacement, but these are the changes that are taking place. Because supposedly if it's given in the question that a particle A, this particle is moving from A to B point, okay, and it will be like the question will be giving you the initial conditions that for the particle at point A and the particle when it is at point B. Then in that case you'll be putting the limits here and here. This will be the initial x limit and final x limit. This will be time initial, time final. And here in acceleration also you can do it the same way, that a dx is equal to v dv. We can again put limits to it, but whatever the question says you can do it that way. Now let's start with the questions. Okay, that is more important than any theoretical knowledge that you know. The first question that I'll be taking here will be based on your uniformly accelerated motion. It will be quite easy to understand with the question, what the question says. The question says, I'll be reading the question, you can understand it. It says a ball is thrown upward from the top of a tower 40 meters high. That means there is a tower, okay, this is the tower from the ground level and it's 40 meters high, and there's a ball which is thrown upward from this point with a velocity of 10 meter per second. Now the question says find the time when it strikes the ground. Okay, and it's given that acceleration due to gravity, that is g, is 10 meter per second square. Now the basic question is this only. It's very simple, as you can see. Now I'll be telling you about the sign convention, because that is the most important thing in this chapter. Solution. Okay, solution would be what? It's very simple. This particle will definitely be going up from here. It will reach its highest point, and definitely from there it's gonna fall down. Okay, suppose this ball is at this edge, obviously it will fall down. So we need to calculate the time it will take to hit this ground at this point. So how much time is gonna take? It's very simple. We'll solve this question phase by phase. We'll consider this point as A, this point as topmost point as B, and this point as C. Okay. Okay. What equation? Let's write the first. We're going to write the values. First is I'm considering upward direction as positive and downward direction as negative. This is my sign convention that I'm taking here in this question. It can vary according to you. So let's take it upward as positive. So anything which is moving towards upward will be positive, and anything that is moving downward will be negative. So for phase, for A to B in the particle, okay, initial speed of the particle will be what? Which will be 10 meter per second square. It will be positive, because the particle is going upward and it is pointing towards this arrow, which is taken to be positive. And when the particle will reach at point B, what will be the velocity of the particle at point B? Obviously it's going to stop there and then move down. The final velocity of the particle for A to B region will be 0, and 0 does not include any sign. Okay, now the next point is, what is the acceleration due to gravity? What is the acceleration due to gravity? Obviously there is Earth here, we are on Earth, and Earth is going to pull anything which is going up, it's going to pull down. So acceleration is downwards. So G, they've given the value of G as 10. You'll write the value of acceleration due to gravity 10 meter per second square. What will be the sign convention? Since it is pointing downwards, it will be negative. So you've got the sign convention now. It's very easy for you. So let's solve it. First you need to calculate the time to reach point B. How will you calculate that? V is equal to u plus at. V is 0, initial speed is 10, acceleration minus 10, and t. You'll get time to be 1 second. But the problem here is we've got the time for A to B motion when the particle was moving from A to B. Let's go for B to C point. Then we'll add up the total time, we'll get the total time. Okay, for B to C region, initial speed will be 0 again. Why 0? Because the main reason is that when it will be traveling from A to B, it will be stopping here at this point, and that will become its initial speed. Because these equations, like all the three equations that I told you for uniformly accelerated motions, all the three equations are applied between any 2 points chosen according to you. So you'll be like judging the points. So I've taken it u to be 0. Final speed will be v at this point. Final speed will be v at point C. And acceleration due to gravity is downwards, which is this time it will be, what is the acceleration? It's again minus 10. Okay, and we need to calculate the time. Let's apply it. And do you know the distance? No. First we'll calculate the distance from A to B. Displacement in this case will be S is equals to ut u into this t plus half a t square. This much will be 10, then it will be 2 into this will be minus 5. 10 minus 5 will be 5 meters. Means this distance is your 5 meters from here to here. So total distance traveled from B to C will be 45 meters. 45 meters. So we'll calculate it here. It says S is equal to ut plus half at square. These can be applied anywhere between 2 points. This time S will be, the total S is again pointing downwards, since the ball will be going from here till it will reach this point. It's pointing downwards, so it will be negative. S is equals to minus 45. Remember why minus is used, because it's going down and it's pointing this arrow according to me. So u is 0 plus half acceleration again minus 10 and the t square. You'll get the time again. So minus and minus will be cancelled. 45 into 2 is 90. 90 divided by 10 is 9 is equals to t square. So t is equals to 3 seconds. And t is also equals to minus 3. Remember, there's a square here. What you will do here is t is equals to plus minus root of 9, which is plus minus of 3. Obviously there will be 2 options available here. So now we are going to calculate the total time taken for the whole journey. T total will be equal to this 5 plus this 3. Either this is correct or 5 plus of this time. This will give you 5, 6, 7, 8. This will give you 2 seconds. So we've got 2 values here. Okay. Let me just recheck it. Is it correct? So and then we will see. Okay, I was thinking that something is wrong. We are calculating total time. So the time was t is equals to 1 second. This will not be 5. This is displacement. So it's 1 here and 1 here also. 1 plus 3 will be giving you 4 seconds, and here it will be minus 2 seconds. So these are the 2 answers available. Now you must be thinking, how can we get time to be negative? What's the significance of minus 2 here? I'll tell you what's the significance of it. Since when we started from this point, okay, we calculated the t to be 0 here. When we moved upwards, everything will be positive. Time came out to be how much? Came out to be 4 seconds for the whole journey it took. Okay, and another last 2 seconds was the ball could directly go from here till here. This time t will be here equals to minus 2 seconds. That is why we've calculated the 2 times. We are going to neglect the negative number, negative time. So the final answer is this and not this. I hope it's clear to you. Thanks for watching. Subscribe to my channel to stay updated for more videos.